So welcome to Zoom of Scientists. This is a series sponsored by Lake Champlain Sea Grant and UVM Extension and SUNY Plattsburgh's education program known as Watershed Alliance. Lake Champlain Sea Grant develops and shares these science-based knowledge to benefit the environment and economies of the Lake Champlain Basin. And they aim to reach K through 12 students and their teachers through the Lake Champlain Basin. Our goal is to increase awareness and knowledge of watershed issues to youth throughout Vermont and New York. And Zoom of Scientists was created in response to the need for more virtual programs in the current state of education. And these webinars will also be uploaded to YouTube. So if you miss a webinar and you want to watch it at a later time, you can join our YouTube channel and watch it at any time you like. So today we would like to introduce Curt Stager, who is an ecologist, paleoclimatologist, and science journalist who has written multiple periodicals in National Geographic and the New York Times. And in 2013, he was named the New York State Professor of the Year by the Carnegie Foundation. He currently teaches at Paul Smith's College in the Adirondack Mountains in upstate New York and holds an associate's post in Queen's University, Ontario, where he continues to investigate long-term history of climate in Africa and the northern US. In today's presentation, Curt is going to explain to you guys how global climate change is not only about polar bears and far-off places like we sometimes think, but it's also something that we experience here in Vermont. And this comes from a wide range of sources such as weather data, ice out contests, and nature diaries. And these changes are being noticed by regular folks like you and me, as well as experts. So we'll discuss the nature of these causes and the changes as well as what they could mean for the future of this region.
All right, Curt. So if you want to take over screen share and
Sure.
Take it away. Your audio sounds great.
Okay. Just kind of get this rolling here, get the chat out of the way.
Yep. We can see your screen now, and
Okay.
PowerPoint looks good.
Okay, I'm going to try to hide the thumbnails there. Okay. Yes. All right. So welcome everybody, and thanks for your time. This will be just an overview of evidence that colleagues and I, local residents and all in the Champlain Basin, especially in the Adirondacks, evidence we found that the climate is changing here too, which of course, you know, we sort of know anyway, you expect it from the global climate change. But anyway, I'll give you some facts and figures and sources of this information, and then maybe go like 15 minutes or so, and then just open for discussion, question and answer. I always like to sort of set the tone here, acknowledging how politicized climate science has gotten in recent years, decades and stuff. Just want to always sort of make the point that science really should serve everybody, regardless of their political background and political interests. And the theme that I like to develop presentations around is a quote from Thomas Henry Huxley from the 1800s, where he was speaking in the context of evolution, which was, of course, also controversial. But he said, we have to learn what is true in order to do what is right. And although science is a flawed tool, it's our clearest window on what physical reality is. So that's the theme and the tone I'd like to take here and just show you what's really going on around here. So one of the earliest written examples of this, and which I think also illustrates the importance of observing and recording what's going on around us today in our lifetimes, is a diary entry from Samuel de Champlain when he came in the 1600s and was paddled along Lake Champlain by some indigenous people. He was observing the surroundings, and he wrote, "I noticed while observing the country some very high mountains on the eastern side, on top of which there was snow. And if he's going down Lake Champlain from north to south, the stuff he'd see on the east was your green mountains over there, covered with snow in July 1609. So, of course, you can always have some snowfall in the highest of the peaks around here in any time of year, but the chances of that being snowy in July were pretty small today. Back then, that was still in a naturally cool time called the Little Ice Age. And so my point here is the climate has certainly changed naturally, and the observations we make today that may seem unimportant could actually help people understand later on, generations who are coming after us, how much the world has changed. And Champlain certainly wasn't thinking of climate change when he wrote that stuff down. Also want to make sure the terminology is clear. I'll be talking about climate, not weather so much, and that's important to make clear to folks too when you talk about this subject. So weather is basically short-term, small-scale phenomena, kind of the ups and downs in a road, let's say, going up into the mountains. Climate is the long-term trend or the overall uphill slope. And so I'll be talking about general climate trends. So we've got several reputable weather stations here in the Adirondack uplands. They're part of the U.S. Historical Climatology Network. The data from these are freely available online. And if you plot the last 110, 120 years of records from Lake Placid, you see a pretty clear overall increase in temperatures, and especially in recent decades, so like the last half century or so, starting, let's say, the 1970s. It's been increasing, erratically, but pretty steeply. And that's in keeping with the global warming as well. That's about the time frame during which the human influence on global climate has become pretty noticeable and distinct from the natural variations like the Little Ice Age and things like that. So if I've got a student right now reanalyzing all of these records, and we're going month by month and whatever with these different stations. But the basic pattern is most of the warming is concentrated in December, January, February, up here in the uplands anyway, and also in the summer, July, August, and September. If I remember correctly, September actually has the most warming of all. So that means if you're keeping phenology records, or in other words, monitoring the responses of plants and animals to these climatic shifts, if you do it in the spring when a lot of people do it, you may or may not get a clear signal as to whether living beings are responding to this or not, because the changes in spring are actually not as great as in the dead of winter and the dead of summer, basically. So we've got observational records here at Paul Smith's College that go back to about 1990 for things like when do the robins arrive in the spring, when do the spotted salamanders migrate, when do the red maple buds open, and things like that. So it's a mixed bag of responses. The robins are coming significantly earlier, the salamanders are migrating significantly earlier, but the red maples are not. So it's interesting that different species are responding in different degrees to this. It's not a clear-cut thing. So it's actually advisable, if we're going to do these kind of measurements, to try to do it in the time of year when the biggest changes are happening, because these are still relatively subtle. But the thing you can expect from this kind of a pattern with the biggest warmings happening in the winter and summer is that overall, in general, the winters here are getting shorter and milder on average, and the summers are getting longer and hotter, especially in the tail end where it stretches into September. So we've got lots of evidence, in addition to the actual weather records, of responses to this. So we've been monitoring since the 1970s the ice out dates on Lower St. Regis Lake, and that's a common thing. People do it all over the North Country. There are ice out contests that people use to gamble on when the ice is going to leave in the spring, and that's kind of, people are kind of waiting for spring to show up. And folks tend to be pretty methodical about this because money is involved. So if you find these records, you can plot them out and you find clear evidence of later freeze-ups and earlier ice outs on the order of 10 days or almost 2 weeks now difference since about 1970 on our lake. Similar thing on Mirror Lake, Lake Placid. And one of the really dramatic changes is on Lake Champlain. These are data you can find online. I believe it's NOAA, but you can go to a NOAA website with this. These are dates when the main basin of Lake Champlain did not freeze over completely in the winter. So this timeline here goes from the early 1800s, from left to right, up to close to the present day. And I've put a little asterisk on the winters where the lake didn't totally freeze over in the center. So that'd be basically between Burlington and Plattsburgh. And if you read it from left to right, you'll get like 3 asterisks during the first 100 years or so. And then they become more and more common, so that by the time you get into our present times, it's more normal than not to have that water be open. So the implications of that are big. They also then affect people and the lake itself and the things that live in it. So some of you may remember, I remember when I was first up here some decades ago, there were always in the spring big shanty towns of ice fishing that would get broken off on floes of ice and be drifting around and stranded, and it was a big news story and stuff in the spring. So that doesn't happen so much anymore because that part of the lake doesn't freeze. This is where the ferries go across. Also, the Grand Isle Ferry, for example. I've spoken to some of the ferry operator people like Russell Fox here and others, and I said, what is that like for you folks to have less ice on the lake in the winter? And I thought, well, isn't that better for you? You don't have to break the ice, right? So doesn't it save gas and stuff? And he said, well, it's a mixed bag. If the lake is unfrozen, then that means if it's stormy and windy, you get these big storm waves, which are also problematic for ferry travel as well. And he even said, if you're an experienced ferry operator, you can feel the difference between waves in the winter and waves in the summer when they strike the ferry, because in the winter they're colder and so they're denser and they hit with a lot more force. So he said personally he prefers to have a frozen winter because at least the travel is calm. So, with climate change, it's not just temperature, right? There's precipitation involved. And if you take the weather records from the Adirondacks, you also have been getting an increase in overall precipitation, especially in just the last few decades. And we can see evidence of that even without the weather stations. So if you come up here into the uplands and pay close attention to the shorelines of the lakes around here, you can see pretty clear evidence of water levels going up. This is Bear Pond. John Stetler, who's in the group here, has studied this lake with me and other folks as well. This picture on the left is of a spot that used to be a little island with a tree growing on it and a grassy spot. And if you look carefully up on the stem, I've circled in red here a no camping sign from the DEC, state rangers. So as you can surmise, there's not much risk of people camping there anymore because the water level of Bear Pond has come up on average now, drowned the tree and covered the little island. And if you look over to the right, that's also from Bear Pond. And you can see these tree roots poking down into the water. And of course, trees don't take root underwater. So if you see something like this on a local lake, you can be pretty sure it's a sign that the water level has come up. And that can be common, in the spring, let's say, for a lot of places. But this is chronic now around a lot of the Adirondacks. So you can see signs of this greater precipitation. In addition, just like you are seeing globally, as the atmosphere is heating up, becoming more laden with water vapor evaporating from the oceans and trees and things like that, the intensity of rainstorms is going up globally on average. And we see that here too. So I've got some charts here. One is from Cornwall, Vermont. One is Dannemora. And basically just added up from the last century or so, how many rainstorms dropped 2 inches or more in a single day. And if you plot those over time, the average, the size of the extreme rainfall events the amount of water dropped in a single rainstorm has been increasing significantly in both of these locations over time. So basically, the extreme rainfall events, or what used to be classified as extreme, have become more common. Or another way to say it is the extreme rainfall events have become more extreme. So this illustration here is from when Hurricane Irene, or Tropical Storm Irene, came through. And this is the village of Keene in the Adirondacks here, where a small stream jumped its banks and tore through the town, wiped out people's yards, and smashed houses. So on the other side here for Lake Champlain, that spring of 2011 was another case in point. Spring is always the high water time at Lake Champlain, but this one in particular was extra large. And ironically, it was a major hassle for the ferry service because their office in the south end of Burlington is right on the water's edge. So the ferry service had to keep operating as best they could, at least with the ramps that were working. But the actual workers had to take rowboats out to their office to get to work. And I was given photos from Russell Fox here. This is inside one of the work areas there. These are folks who had to work in rubber boots and then hip waders and then chest waders for day after day after day. And the reason I'm showing you this is because if you look behind this person here in the checked shirt, if you look to their beside their right arm against the wall where the water line is, once the water started to recede, they drew a horizontal line where the high water mark was, and they dated it. When I went to visit that garage, you could see that line, and then you could see another line just below it with a previous date, and another line below that with a previous date. So what we're seeing there is a steady increase in the intensity of the high water stands documented on the wall of a maintenance shed with the ferry service. So there are all kinds of consequences. If you have this more intense flooding, in the case of Lake Champlain, that's of course going to deliver more runoff that's full of phosphorus. So the sediments coming in this case on the New York side in here, eroding more, coming into the lake and adding nutrients to the lake. Or if the water level comes up, it erodes the headlands and puts more phosphorus in. And of course, there's a lot of trash that washes in. The ferry people said they had to keep pulling debris out of the propellers of the ferries, especially in that spring. But of course, then the result of this is you're putting more nutrition into the lake, is you can potentially be stimulating more growth of plankton, phytoplankton. So that could be algae or cyanobacteria. And here's a split rock on the New York side of Lake Champlain. In June, after that wet spring, and you can see the green color of the water there, partly due to the greater inputs of phosphorus from that wet spring that was there. So this is a chronic problem. Maybe John Stetler wants to speak up on this. He studies this sort of thing too. Here's a picture of Bear Pond again. Back in the 80s, when I first knew that pond, it was locally famous because it was so beautifully crystal clear. If you go there today, it looks kind of murky, not too bad, but kind of like your average lake. So it's not unusually clear. It was spectacularly sky blue. So one of the reasons for the change is one thing we didn't realize at the time that makes it maybe a little less attractive in the past, and that's because it was heavily acidified by acid deposition. So since passage of the Clean Air Act, the lakes and streams up here in the Northeast have been recovering as the acidity of rain declines. So that was part of it. But there's another thing going on as well that contributes to this. It's called browning. And that's partly the result of the end of acid rain, you could say. That frees up a lot more microbial decay in forest soils around the water bodies. And that plant debris can now be breaking down. It's like tea, basically. So what you're doing is turning the lakes into forest tea. But also, this happens as well if the climate becomes warmer and wetter. So all of these three things are working together to cause this widespread darkening or clouding of a lot of the lakes around here. Combination of the change in our kinds of air pollution, basically less acid rain and more of the climate change. In the case of Bear Pond, it's not so much brown, but there's nutrition in the stuff that's washing in as well. And it's basically producing more phytoplankton as well. And so you could call it greening instead, like that. The bottom line of this then is, as we have this amazing success story of recovery from acid rain due to really good legislation, passage of the Modified Clean Air Act and things like that, the lakes or ecosystems aren't just returning to their original state. They're being skewed into novel ecosystems in ways that they've never been before because the climate is changing underneath them. So they're not going backwards, they're going sideways, you could say. So 10 years ago, Mary Phil from the Nature Conservancy and I just did an overview of climate change in the Champlain Basin. It's free, the PDF is still online. Just type that in if you want. The findings in there sort of mirror what I've been telling you. They haven't changed that much, so it's still pretty relevant. But the purpose of this slide is to look forward into the future, the near future, just this century here. And we ran 16 climate models, downscaled just to the size of the Champlain Basin. And then did try different settings on these different ones, depending on what our fossil fuel emissions are during this century. And so if you have the moderate emission scenario, there was a range of expected warmings from the different models. They ranged anywhere from 1 to 6 Fahrenheit warmer. We used Fahrenheit just because we were writing for the general public. If we do not switch quickly from fossil fuels and just continue burning as usual, we'd have the extreme emissions scenario, and by the end of the century, you'd get a lot more warming. So these models estimated 6 to 11 degrees Fahrenheit average and slightly wetter as well. So that's what we're looking for. I mean, you don't need a fancy computer model to say that if you continue to emit greenhouse gases, heat trapping greenhouse gases, you're going to make the world warmer. And then we can argue about the exact amount. So getting close to wrapping up here and opening up for discussion, to get back to that theme of Samuel de Champlain taking note of what seemed like unimportant little details of how the world was when he was there, and then finding out later after the world changed how important it was. We try to build this sort of thing into how we teach the sciences at Paul Smith College. And I recommend people who are at high schools or colleges or nature centers or anything like that to do as much long-term ecological monitoring of your surroundings as you can, partly because the world is changing around us, and also because it's good pedagogy. It's a good way to teach. In this case, these are Biology 1 students who are out collecting plankton from the lake on campus here at Paul Smith College, rather than ordering microbes from a supply catalog. Let's say we go out and actually collect the stuff from the actual lake. And the students also take the temperature of the water. We've been doing it since 1990, and we see a pretty major warming in September of the surface temperatures here. And, you know, you can argue the validity of these data because they're from brand new freshman students, but the numbers of data points are large enough that I think it's valid and it fits the weather records. So we can watch the lake starting to warm up. That has pretty serious implications for lakes, of course, because if you warm up the top, you stratify the lake more, and you can affect the oxygen dynamics down below or the temperature tolerances of the fish. So that's a serious problem for anybody concerned about trout, let's say. They tend to need cooler waters. There's pretty good evidence that lake trout and brook trout are declining in a lot of our lakes. And the most likely culprit, in addition to multiple causes, the most likely universal culprit is the warming trend, because if you keep your lake warmed on the top, stratified off, isolating the deeper bottom waters, they're more likely to run out of oxygen, and the cold water refuge is no longer so good. So this is a photo of Fallensby Pond near Tupper Lake in the Adirondacks that's now being managed by the Nature Conservancy as a long-term climate refuge for lake trout. And basically, in the context of this changing climate we've got, very deep lakes such as this one have an added value because it's deep enough to not be so vulnerable as a more shallow lake would be. And so therefore, if you're going to try to preserve lake trout, that's a good kind of a lake to do it in. So closing here, with all that doom and gloom, keeping in mind, I think one of the things Champlain had kind of been looking around for when he was snooping around here in the 1600s was places to grow things, right? And so, you know, as the world changes, we've all got our different values, and there are always winners and losers in every story. And if you want to look for one small bright spot, maybe, as the climate is warming around here, I'm told by grape growers that the Champlain Valley is becoming more and more amenable to growing grapes. And there's now a Champlain Richelieu International Wine Trail. So maybe it'll help you drown your sorrows a little bit. So I'll leave it there and stop sharing, and let's see how chatting or talking works. I've got my phone here.
Awesome. Thanks, Curt. Really appreciate it. I didn't realize that the Champlain Valley was on the short list of places to turn into the south of France as we move forward. I'd heard a lot of potential impacts of climate change, but better grape growing climate. I hadn't heard that one yet. So there we go. There's always something, right? Always an upshot. Cool. So for those of you with us, navigate down to that Q&A button. It should be on the bottom of your screen or the top. You can open that up and put your questions in there, and I'll read them off for Curt so he can answer them. While you're thinking of questions and typing those in, Curt, we usually start off with the same question for most folks. If you'd be willing to talk about sort of your initial interest in climate science. I know you're very experienced. You've been doing this for a number of years now. But if you want to talk about, kind of what pushed you to begin studying climate science, or what initially, sparked your interest in this field?
Yeah, I started working with climate as actually long-term climate change or paleoclimate as a grad student at Duke University in 1980. We worked in Africa on the African lakes, and we were reconstructing climates to tell the story of evolution, human history, fish evolution, rainforest ecology, things like that. So got onto the climate theme that way. But then as global warming became more popular and gained wider interest, then my interest moved closer and closer to the present day rather than ice ages and those natural cycles and things to see what we can see going on around now. And then coincidentally, Bill McKibben, as you may know that name, as a climate activist, became a trustee of Paul Smith College for a while. And because I was working on climate, he was writing articles about climate change. He wanted to know my opinion, and I basically said, well, I don't really know what's going on in the Adirondacks. How do you find out? So I found some old weather records. They didn't show much warming. And so I presented them to Bill. He didn't like that. He wrote an Adirondack Life article where he called me one of the few remaining climate skeptics. But from that experience, then I well, how do I know this is right? And it turned out the data were flawed. And so because of that experience, I got personally interested in say, okay, what are the real numbers for the North Country? And that got me on the track of the US HCN weather data stations and doing those kinds of analyses. And then also keeping a nature diary, which I highly recommend. Starting in the late 80s, I was writing down, when the birds come and when the flowers open and stuff. And that matched with the temperature data. pretty in interesting ways. And then the last bit was, as it got so politicized, my natural inclination is when somebody attacks science, I want to stand up for it. So that was also a strong motivation to keep digging into the numbers.
Awesome. Appreciate that. Yeah, I've heard you speak about that sequence of events with Bill before, about you being one of the last remaining climate skeptics. I always find it really fascinating. Cool. Thanks for that. We have a question from Catherine. Thanks, Curt. Your presentation focused more on precipitation. What about drought? Currently in Vermont, the conversations I hear are focused on drought caused by climate change. Is drought just the current situation? So getting at that weather, instance of weather or climate, I suppose.
Yeah.
While increased moisture is the long-term projection. So more precipitation, less precipitation. What do we got?
Yeah, the answers to these kinds of questions have a lot to do with the time scale you're talking on. So the rainfall records that I showed you from the Adirondacks are pretty similar to what you get in Vermont too. Of course, we're part of your watershed anyway. So since around 1970, the average amount of rain has gone up, and then it fluctuates around that average. And then in the last decade or so, it jumped again and fluctuates up and down. So we can certainly get droughts. They can last months or even a year or two without ruining a trend like that. So the overall big pattern is the Northeast has been getting wetter in recent decades. The Southwest has been getting drier. So we hear about the droughts and fires out there. So that's generally that. But the other thing is, as the temperature goes up, you can also get more extremes. So when it doesn't happen to be raining a lot, having higher temperatures increases the evaporation rates. So you can drop a water table, you can drop a lake level, things like that, and notice it. So what we would expect from a warming climate in a place like this is more extremes of drought and heavy rainfall. When it gets wet, like super wet storm, it should be, becoming more powerful on average. And then in between the wet periods, the evaporation rates can help drop the groundwater levels.
Awesome. Thanks, Curt. Appreciate that. We just had another question come in from my colleague at Sea Grant, Juliana. As you said, climate change is a global problem with local consequences. Wait, sorry, I haven't read through this first. We can reduce we can reduce our own carbon footprint, but are there specific things we can do to preserve or protect ecosystems locally? So, and then she puts thinking of a trout sanctuary, like you had mentioned. Yeah. Let's be clear.
That's a great question. The people who live here know this place better than anybody else. And so these general global things are coming from folks who don't know the Champlain Basin. It's people like us, just regular folks living on the land and watching what's going on, who are the best sources of information of what we should be doing. And so as a general rule of thumb, it's depressing, but the changes going on with climate are generally going to amplify all the other environmental problems that are going on. If there's nutrient enrichment in the lake, right? Or, cyanobacterial blooms from the stratification or invasive species, all of these things can be amplified by the climate. So what it basically does is intensify the need for getting to know your corner of the world and doing everything you can to protect it, and understanding how it works, and then using that with the basic rule of thumb that this place is going to continue to get warmer. And by the way, it's not just for a few decades, it's thousands of years. It's going to be warming, probably. So kind of a permanent thing. So we've got a shifting baseline for our ecosystems. And so, for example, to protect a lake from, let's say, worsening of algae blooms, all of the efforts we're doing now are going to need to be increased in a warmer, wetter future, because the inputs are going to increase and the stratification of the lake's going to do it, right? Another thing is, if you're trying to preserve a habitat for some sort of a species, you can use common sense, right? Think about what it's going to be like in decades or a century or two from now. It's going to be warmer, and so the elevations at which you find habitats, now that's oversimplifying, of course, but in ballpark, it might be more amenable at a higher elevation. So if you have topography in your preserve, there might be a little more resilience in there. So I don't want to oversimplify that. It's controversial ecology, but basically take the place and imagine it being warmer and somewhat wetter. And that's what you got to do to take better care of it. It's a moving target now. There's a good way to put it. I heard someone compared it to Alice in Wonderland. There's a character in there called the Red Queen who Alice meets, and the Red Queen is running and running and running in order to stay in one place. And that's kind of what we have to do with our ecosystems now that the ground is moving from under us with the climate. We've got to run harder and harder just to keep things the way they are.
Thanks, Curt. Appreciate the honesty with which you approach those kind of questions. Are tough to talk about, especially when talking about places that are near and dear to people's heart. But I think your point, I particularly grab onto getting to know our corner of the world as best we can, so we can try to, buffer whatever changes we're seeing, or pay attention to special corners that we think hold, a good bit of resilience and integrity. So I appreciate that. I'm going to ask you one last question. And for folks that are still on with us, looks like most folks have stick around. Please continue to stick around if you can. I'm going to launch a feedback poll while Curt answers this final question. And then I'm going to talk through our next session that's coming down the line. So Curt, last question from Brenna. Thank you, Curt. I'm wondering how you think climate change will affect the economy and culture of the Champlain Basin. So we talked about the grape growing. I'm wondering if you have any other thoughts you'd like to share about the potential effects of economy and culture in the basin.
Yeah. We can only speculate, right? Humans are very difficult to predict. Like, who would have predicted the internet, years ago and stuff. But there's some things. If winter is a big thing for us, and it helps to define our culture. Like up here in the mountains, right? I'll talk to folks who run like the mountaineering stores and things like that. What do you think this is going to be like? And they basically said, well, if the climate here becomes more like the Blue Ridge is beautiful, right? We got banjos down there and people like it and stuff like that down there. And okay, but the difference is we've got winter here. And winter is what defines us in the North Country as different from the mountains down south, let's say. It brings out a certain kind of self-reliance, right? And we've got the Olympic history here, let's say, and the winter sports, right? Stuff like that. So there will have to be big cultural changes as winter starts to shrink and it becomes less of a basis of our economy. I'm somewhat optimistic that it will probably happen slowly enough that old folks will remember how it used to be and, kind of miss those old days. The younger folks born into it will think, well, that's just the way it is. Okay, I'm going to have a different kind of business. But I see that as the long-term trajectory. And so, like we got the apple industry over here, right? And around Plattsburgh and stuff. At some point, the climate may not be so great for apples, but maybe it'll increase for grapes or something like that. But whatever it is, it's going to have to deal with warmer temperatures and more intense rainfall events or snow events if they happen. Of course, the snow is going to be more as rain over time too. So yeah, it's anybody's guess. You can speculate too, right? I know, Brenda, what do you think? What's it going to do to the culture and economy in the Champlain Basin, like 100 years from now?
Yeah, that's a great question. Brenna, type
Can
your
you unmute maybe, or
Yeah.
is there a way to get a response
No,
from Brenna?
Sam says no skiing with a frowny face. I'm in the same boat. I'm a big skier, so I know all of the projections I've seen about snow cover in the Adirondacks have been pretty tough. But yeah, Brenna, if you have any ideas, type them in the chat to Curt about what you think some of the biggest impacts will be. Curt, is it all right if I share your email? Sorry, I didn't clear this with you ahead, so folks can follow up with you. Great. So
Yep.
I'm going to drop Curt's email in the chat. So folks, feel free to jot that down and communicate with Curt directly if you have any follow-up about today's presentation or Curt's work in general. Curt, again, thanks a lot for this. Folks, I have a take-home activity that I'd like to assign with you all. Ooh, before we do, Brenna did type in a response. I agree. I wonder what the culture of the North Country will be like without the defining season of winter. Perhaps more interest in other activities that are done during other seasons. Yeah, perhaps. Okay, so take-home activity. So I thought it would be fun if folks want to share a courageous conversation with someone that you know. So plan out a conversation you could have with someone in your life about climate change in the Lake Champlain Basin. Maybe you want to share something you learned today from Curt. Maybe you want to talk about data. Maybe you want to talk about your vision for the future. So just bring it up. Have a dinner table conversation about climate change, what it means to you, how some of these projections make you feel. Maybe you want to just do it as like a journal entry, or you want to write it out as a story, or maybe you are pretty artistic. You want to draw your vision for the future, hopeful or pessimistic, whatever you want. But also, share those with us on social media. I'd love to see them at Lake Champlain Sea Grant on Instagram or on Facebook. You should see some links coming into the chat. I found a PDF from that Nature Conservancy report that Curt had mentioned. Also a link to the Lake Champlain Basin program has a pretty good landing page for some climate data as it pertains to the basin. And then if you want to join us in a couple of weeks on October 30th, we're going to have Bill Ardren from the U.S. Fish and Wildlife Service come and talk about landlocked Atlantic salmon in Lake Champlain. So there should be a link to the virtual learning page in the chat. You can click on and register for that session on the 30th. Just a little bit about that talk. So by the 1850s, dams, habitat degradation in rivers, and other factors had eliminated landlocked Atlantic salmon from the Lake Champlain Basin. Restoration efforts, including hatchery culture, stocking, and sea lamprey control, have been successful in restoring the lake fishery valued at more than 200 million, but depends on ongoing stocking. Dr. Bill Ardren has developed a series of large-scale adaptive management experiments to restore naturally reproducing salmon with the goal of fish returning to multiple tributaries, migrating upriver, spawning, and producing fry that will lead to self-sustaining populations. Working in cooperation with federal, state, local, and university partners, Bill's innovative scientific inquiry and applied research to guide restoration has focused on addressing the primary factors limiting salmon reproduction, including fish culture and stocking, imprinting and homing, thymine deficiency likely caused by consumption of non-native alewife that are now present in the lake, downstream fish passage, and habitat restoration. So if you want to come learn a little bit about salmon, please do register for that talk on the 30th. And with that, I will say bye to all of you. Curt, again, thank you. It's always a pleasure. I really appreciate you taking the time. And we will see you all next time. So take care.